Imagine the vast, dark expanse of space. It is a cosmic ocean, teeming with celestial bodies, each on its own grand journey. Amongst these travelers is an asteroid, a rocky relic from the early days of our solar system. This particular wanderer, catalogued as Asteroid 387746, or more commonly 2003 MH4, is currently hurtling through the void, its path set to intersect with Earth's neighborhood. It is a reminder that our planet is not isolated but part of a dynamic and ever-changing cosmic environment. We are but a small stage in a vast cosmic arena, as the late Carl Sagan so eloquently put it. The universe has a schedule, and on May 24, 2025, Asteroid 2003 MH4 has an appointment near Earth. Precisely at 10:37 Coordinated Universal Time, which translates to 4:07 p.m. Indian Standard Time, this significant piece of solar system debris will make its closest approach to our homeworld. This event is not a surprise. Astronomers have been tracking this object for years, calculating its orbit with remarkable precision. It's a testament to human ingenuity that we can foresee such celestial encounters, turning potential surprises into opportunities for observation and learning. The cosmos operates on grand timescales, and this flyby is but a fleeting moment. This upcoming encounter is more than just a dot moving across a telescope lens. It represents a chance to study these ancient celestial nomads up close, relatively speaking. Asteroids like 2003 MH4 are like time capsules, holding clues about the formation and evolution of our solar system, some 4.5 billion years ago. They are the leftover building blocks, the cosmic rubble from a construction project of immense proportions. Each flyby offers a precious window, a brief moment to gather data and deepen our understanding of these fascinating and sometimes concerning objects that share our cosmic postcode. The anticipation surrounding this event is palpable, not just within the scientific community but also among the public. There is an inherent fascination with these visitors from the depths of space. They fuel our imagination, reminding us of the grandeur and the potential hazards of the universe we inhabit. As 2003 MH4 makes its swift passage, it serves as a stark reminder of the celestial traffic that constantly crisscrosses our path. We are, in essence, living in a cosmic shooting gallery, a realization that humbles and inspires in equal measure. Consider for a moment the sheer speed of this cosmic voyager. Asteroid 2003 MH4 is not merely drifting through space, it is careering along at an astonishing velocity of 14 kilometers every single second. To put that into a more Earth-bound perspective, that is approximately 50,400 kilometers per hour. This is a speed that dwarfs any terrestrial vehicle, a testament to the immense gravitational forces that govern the dance of objects within our solar system. Such velocities are common for asteroids, a consequence of their long journeys around the Sun, accelerated by its powerful gravitational pull. This incredible speed means that its encounter with Earth's vicinity will be relatively brief, a fleeting passage in astronomical terms. Yet, it is this very speed, combined with its size, that places it on the watch list for organizations like NASA. The kinetic energy carried by an object moving at such a pace is immense. Understanding its trajectory, the precise path it carves through the solar system, is therefore of paramount importance. Astronomers meticulously plot these orbits, using observations from telescopes around the world and in space, refining their calculations with each new data point. Asteroid 2003 MH4 is classified as belonging to the Apollo group of asteroids. This isn't just a casual label, it signifies something crucial about its orbit. Apollo asteroids are defined by their orbital paths that cross Earth's own orbit around the Sun. This characteristic inherently makes them objects of interest, as their paths can, over vast timescales, bring them into very close proximity with our planet. The orbit of 2003 MH4 around our star the Sun takes approximately 410 days to complete, a celestial year slightly longer than our own, bringing it periodically back into our cosmic neighborhood. The journey of 2003 MH4 is a predictable one for now. Its current trajectory is well understood thanks to the diligent work of astronomers. They can forecast its position with remarkable accuracy, allowing us to prepare for its close approach and to study it as it passes. This predictability is a cornerstone of our ability to assess any potential risks and to appreciate the intricate, clockwork nature of our solar system. It is a dance of gravity, played out on a cosmic scale, with each participant following a path dictated by ancient laws of physics. When we speak of asteroid 2003 MH4, we are not discussing a mere pebble in the cosmic stream. This celestial object possesses substantial dimensions. It is estimated to be approximately 335 meters wide. To truly grasp this scale, imagine the iconic Eiffel Tower in Paris. 2003 MH4 is roughly equivalent to its height. Picture a skyscraper soaring 100 stories into the sky, or perhaps envision the combined length of 3 professional football fields laid end to end. This gives you a tangible sense of the sheer bulk of this ancient space rock. Its considerable size is one of the primary reasons it commands such attention from the scientific community and space agencies worldwide. An object of this magnitude, were it ever to collide with Earth, would not simply burn up harmlessly in our atmosphere. Instead, it would unleash a tremendous amount of energy, capable of causing significant devastation on a regional scale. It is this potential, however remote for this particular asteroid at this time, that underscores the importance of tracking and characterizing such celestial bodies. Knowledge in this cosmic context is our first line of defense. The term massive asteroid is often used in popular descriptions, and in the case of 2003 MH4, it is entirely appropriate. Its mass, though not precisely determined without closer observation, would be considerable, contributing to the immense kinetic energy it carries due to its high velocity. The combination of its size and speed makes it a significant object in the catalog of near-Earth objects. We are dealing with a substantial piece of cosmic real estate, a fragment left over from the primordial disk of gas and dust that formed our Sun and its planets billions of years ago. Understanding the physical characteristics of asteroids like 2003 MH4, including their size, shape, and rotation, is crucial for several reasons. It helps scientists refine models of asteroid populations, aids in assessing any potential impact risk, and provides valuable data for planning future missions, whether for scientific study or planetary defense. Each new observation adds another piece to the puzzle, helping us to build a more complete picture of these fascinating and sometimes formidable celestial neighbors. The universe is filled with wonders, and 2003 MH4 is one such wonder we can observe. Asteroid 2003 MH4 carries a specific designation that might sound alarming. It is classified as a potentially hazardous asteroid, or PHA. This label is not assigned lightly. It comes with a set of well-defined criteria established by the international astronomical community. For an asteroid to be deemed a PHA, 2 conditions must typically be met. Firstly, its diameter must be 150 meters or greater. As we've established, 2003 MH4, at 335 meters, comfortably exceeds this threshold, making it a sizable object of concern. The second criterion for PHA classification relates to its proximity to Earth during its journey through the solar system. Specifically, its orbit must bring it within 7.5 million kilometers of our planet's orbit. This distance, while vast in human terms, is considered relatively close on a cosmic scale. It represents a boundary within which an asteroid warrants heightened scrutiny due to the potential, however small over long periods, for its orbit to be perturbed enough to pose a future threat. The classification itself serves as a flag, alerting scientists to monitor these objects with particular care. It is crucial to understand that the potentially hazardous label does not mean an impact is imminent or even likely in the near future for any given PHA. Rather, it signifies that such an object has the potential to make close approaches to Earth and is large enough to cause significant damage if an impact were to occur. For 2003 MH4, current calculations show it will pass safely by. However, the PHA designation ensures it remains on a high-priority watch list, its trajectory continually refined and reassessed over time by dedicated sky surveys. The very existence of the PHA classification highlights a mature understanding of our place in the cosmos. We recognize that Earth is not immune to impacts from space. Indeed, our planet bears the scars of ancient collisions. By identifying and tracking these potentially hazardous objects, humanity is taking proactive steps to understand and mitigate a natural, albeit low-probability risk. It's a testament to our scientific progress that we can even make such classifications, turning the unknown into the known, and the potentially dangerous into the carefully monitored. Section 5 Close but no cosmic cigar, the flyby distance explained. On its upcoming pass, asteroid 2003 MH4 will not be brushing against Earth's atmosphere, nor will it pose any direct threat to us. The calculations are clear. It will zoom past our planet at a distance of approximately 6.67 to 6.68 million kilometers. To offer some perspective, consider the distance to our own natural satellite, the Moon. The Moon orbits Earth at an average distance of about 384,400 kilometers. This means that 2003 MH4 will pass us at a distance roughly 17 times further away than the Moon. This is, by any measure, a safe distance. While terms like close approach might evoke a sense of doki doki, a Japanese term for heart-pounding excitement or nervousness, in astronomical terms, close can still mean millions of kilometers. The vastness of space is difficult to comprehend fully, but these figures help to contextualize the event. There's no need for alarm. Satellites will not be disturbed, and life on Earth will continue completely unaffected by its passage. This flyby is an opportunity for science, not a cause for immediate concern regarding our planet's safety. Our cosmic neighborhood is vast, and this encounter is well within safe margins. The precision with which astronomers can predict these flyby distances is truly remarkable. It is the result of decades, sometimes centuries, of meticulous observation, mathematical modeling, and a deep understanding of the laws of celestial mechanics. Every observation of an asteroid helps to refine its orbital parameters, reducing the uncertainties in its future path. For 2003 MH4, its trajectory has been tracked sufficiently well for NASA and other space agencies to state confidently that it poses no immediate threat of collision during this 2025 encounter. So, while the asteroid is indeed making a close approach by cosmic standards, and its PHA classification warrants ongoing attention, this particular pass is a non-event in terms of danger. It allows us a fantastic opportunity to observe a significant celestial body from a relatively close vantage point, enhancing our knowledge without presenting any risk. It is a reminder that the solar system is a dynamic place, filled with objects on intricate journeys, and that we are becoming increasingly adept at charting their courses and understanding their nature. Section 6. Eyes on the Sky, NASA's Vigilant Watch and Global Collaboration. The task of keeping a watchful eye on objects like Asteroid 2003 MH4 falls to dedicated organizations around the globe, with NASA's Center for Near-Earth Object Studies, or CNEOS, playing a pivotal role. Based at the Jet Propulsion Laboratory in California, CNEOS is at the forefront of computing asteroid and comet orbits and their odds of Earth impact. They have been meticulously tracking 2003 MH4, using a network of ground-based telescopes and sometimes space-based assets to gather astrometric data, precise measurements of the asteroid's position against the background of stars. Due to its considerable size and the high velocity at which it travels, 2003 MH4 is subject to heightened monitoring. This doesn't imply an immediate danger, but rather a prudent approach to understanding its path with the utmost precision. The scientists at CNEOS continuously refine the asteroid's orbital model, projecting its trajectory far into the future. This ongoing work is crucial for providing advance warning if any asteroid, including this one, were ever to pose a credible threat. Their vigilance is a silent shield, operating day and night. This effort is not solely an American endeavor, it is a truly global collaboration. Space agencies and astronomical observatories from many nations share data and coordinate observations. This international cooperation is essential because near-Earth objects are a global concern, respecting no national borders. Telescopes in different hemispheres and time zones can provide continuous coverage, ensuring that an asteroid is not lost as the Earth rotates. This network of eyes on the sky strengthens our collective ability to detect, track, and characterize these celestial visitors. The monitoring process involves more than just tracking. Scientists also work to understand the physical properties of these asteroids, their size, shape, rotation, and composition. This information is vital not only for assessing potential impact risks, but also for planning mitigation strategies, should one ever be needed. The flyby of 2003 MH4, though distant, provides another opportunity to gather such data, perhaps using powerful radar systems to glean more details about its surface and structure. Every piece of information contributes to our planetary defense knowledge base. Section 7. The Subtle Dance of Gravity, Potential Future Trajectory Alterations. While Asteroid 2003 MH4 poses no threat during its 2025 flyby, the cosmos is a place of constant, subtle change. Over vast timescales, measured in centuries or millennia, An asteroid's orbit is not immutably fixed. One of the primary forces that can alter an asteroid's path is the gravitational influence of planets. Each time an asteroid passes relatively close to a planet like Earth or Jupiter, it experiences a slight gravitational tug. These gravitational nudges, though individually small, can accumulate over many orbits, gradually shifting its trajectory. Another, more subtle influence is known as the Yarkovsky effect. This fascinating phenomenon occurs because asteroids absorb sunlight and then re-radiate that energy as heat. If an asteroid is rotating, this emission of thermal photons is not perfectly uniform, creating a tiny, almost imperceptible thrust. Over millions of years, this minuscule push can significantly alter an asteroid's orbit, causing it to drift inwards towards the sun or outwards into the colder reaches of the solar system. For an object like 2003 MH4, the Yarkovsky effect is a factor that must be considered in long-term predictions. These potential orbital changes are why continued monitoring of potentially hazardous asteroids is so crucial, even those currently deemed safe. What is a non-threatening orbit today might, through these subtle cosmic nudges, evolve into a more concerning path in the distant future. This is not cause for alarmism, but rather for diligent, ongoing science. The work of CNEOS and other institutions involves projecting these orbits far into the future, taking into account all known gravitational and non-gravitational forces to assess long-term risks. Therefore, while we can be confident about the safety of the 2025 flyby of 2003 MH4, scientists will continue to observe it during this pass and subsequent approaches. Each new set of observations helps to refine its orbit further, reducing uncertainties and extending the time frame over which its path can be reliably predicted. This long-term vigilance is the cornerstone of planetary defense, ensuring that if an asteroid's trajectory does begin to shift towards a potential collision course, we would have decades, if not centuries, of warning. Section 8. A rock of significant interest, scientific curiosity and composition. Beyond any concerns about its potential hazard, Asteroid 2003 MH4 is an object of considerable scientific interest. Its reported unusual composition, density, and reflective properties, or albedo, make it a particularly intriguing subject for study. These characteristics can provide valuable clues about the specific conditions in the region of the early solar system where it formed, and the processes it has undergone during its billions of years of existence. Each asteroid is a unique individual, a fragment of solar system history waiting to be read. As an Apollo group asteroid, 2003 MH4's orbital path not only brings it near Earth but also suggests a dynamic history, possibly involving gravitational interactions that perturbed it from the main asteroid belt between Mars and Jupiter. Studying its composition, whether it is primarily rocky, siliceous or S-type, carbonaceous or C-type, rich in carbon compounds and water ice, or metallic or M-type, can help scientists understand its origin and its relationship to other asteroid families and even meteorites that have fallen to Earth. This information helps piece together the complex puzzle of our solar system's formation. The unusual nature of its properties, as noted in some reports, piques scientific curiosity because it might indicate a rare type of asteroid, or one that has undergone specific space weathering processes. For instance, its density could hint at its internal structure. Whether it's a solid monolithic body or a rubble pile, a loose agglomeration of smaller rocks held together by gravity. Its reflectivity can tell us about its surface texture and composition. All these details contribute to a broader understanding of asteroid geophysics, a field that is still relatively young. The heightened global awareness and intensified surveillance surrounding 2003 MH4 are therefore not just about planetary defense. They are also driven by a fundamental scientific desire to explore and understand. Each close approach of such an object is an opportunity to deploy various observational techniques, optical telescopes for light curves and spectroscopy, radar for shape modeling and surface properties, to extract as much information as possible. This asteroid is more than just a point of light. It's a natural laboratory passing by our doorstep. Section 9. Guarding our pale blue dot, the evolution of planetary defense. The flyby of asteroid 2003 MH4, while benign, serves as an important reminder of the ever-present need for robust planetary defense efforts. Our ability to detect, track, and characterize near-Earth objects has grown immensely in recent decades. Continuous monitoring by CNEOS and other global space agencies, Utilizing an array of sophisticated telescopes, powerful radar systems and complex orbital modeling software, forms the backbone of our current planetary defense strategy. These systems scan the skies, cataloging new objects and refining the orbits of known ones. The goal is not just to find these asteroids but to understand the risks they might pose, now or in the future, and to develop strategies to mitigate any genuine threat. This involves extensive research into the physical properties of asteroids, as these details are crucial for designing effective deflection or disruption missions. The recent DART, or Double Asteroid Redirection Test mission by NASA, which successfully altered the orbit of the asteroid Dimorphos, was a landmark demonstration of our burgeoning capability to interact with and modify the path of a celestial body. Future strategies in planetary defense are focused on enhancing our detection capabilities, particularly for smaller but still potentially dangerous asteroids, and further developing and testing various mitigation techniques. These could include kinetic impactors like DART, gravity tractors that would use a spacecraft's mass to slowly tow an asteroid off course, or even more advanced concepts. International collaboration like that seen through the International Asteroid Warning Network, or IAON, and the Space Mission Planning Advisory Group, or SMPAG, is vital for coordinating these global efforts. The encounter with 2003 MH4 therefore highlights the critical importance of sustained investment in scientific research, advanced telescopic technology, orbital simulation capabilities, and global partnerships. While the cosmos can present hazards, it also provides us with the intellect and the tools to understand and protect ourselves. Planetary defense is an ongoing endeavor, a testament to human foresight and our collective responsibility to safeguard our unique and precious world, our pale blue dot in the vast cosmic arena.